What happens when a comet defies gravity and grows a tail pointing toward the sun instead of away from it? That's exactly what astronomers have confirmed with our newest interstellar visitor, and it's revealing secrets from beyond our solar system. In July 2025, astronomers spotted something unusual racing through our cosmic neighborhood. Named 3I Atlas, this object was confirmed as our third ever detected interstellar visitor, a comet that formed around another star system and traveled through the void of space for potentially 10 billion years before passing through our solar system. But 3 Atlas isn't just rare because of its interstellar origin. Recent observations using the powerful Keck Observatory have confirmed it possesses something truly unusual, an anti-solar tail pointing toward the sun rather than away from it, defying what we typically expect from comets. Most cometary tails form when solar radiation heats the comet's surface, causing ice to transform directly into gas through sublimation. This process releases dust particles that get pushed away from the sun by solar radiation pressure, creating the familiar tail pointing away from the sun. But 3I Atlas challenges this model. Using spectroscopic analysis, essentially studying the fingerprint of light reflected off the comet, scientists discovered that large, heavy dust particles are being ejected from the comet's sunlit side. These particles are too massive to be pushed back by solar radiation, allowing them to continue moving forward along the comet's trajectory, creating what appears to be a tail pointing toward the sun. The chemistry of this interstellar visitor presents even deeper mysteries. The spectroscopic data revealed unusually high concentrations of nickel and cyanide in the comet's coma, the cloud of gas and dust surrounding the nucleus. What's particularly puzzling is that nickel is concentrated much closer to the nucleus than the cyanide, extending only about 594 kilometers compared to cyanide's 841 kilometers. This chemical distribution doesn't match what we typically see in solar system comets. The production rate of nickel relative to cyanide is significantly higher than in our previous interstellar visitor, 2I Borisov, and orders of magnitude above what we observe in comets that formed within our solar system. Scientists theorize that these metals might be attached to complex carbon molecules called PAHs, forming nickel PAH compounds that are easily broken apart by sunlight. This would explain why the nickel appears so concentrated near the nucleus. It's being released from these compounds relatively quickly after they're exposed to solar radiation. What makes these findings so valuable is that 3I Atlas essentially functions as a 10 billion-year-old time capsule, potentially preserving material from the earliest days of another solar system's formation. By studying its composition and behavior, astronomers gain unprecedented insight into star systems we could never directly visit. While some have speculated about artificial origins for interstellar objects, the evidence overwhelmingly supports 3I Atlas being a natural phenomenon. Its unusual features reflect the diversity of cometary formation processes throughout the galaxy rather than intelligent design. As 3I Atlas continues its journey through our solar system before returning to interstellar space, astronomers will gather as much data as possible. Meanwhile, the upcoming Vera-C Rubin telescope promises to significantly increase our ability to detect more interstellar visitors, potentially revealing whether 3I Atlas's unusual features are cosmic outliers or common characteristics of objects from beyond our solar neighborhood. This interstellar visitor, with its backward-pointing tail and unusual chemistry, reminds us that the universe still holds countless surprises, even in objects that have been silently traveling through the cosmos since before our planet existed.